All right, so reciprocal inhibition. When we hear that phrase, it's typically described as the agonist causing the antagonist to relax. Some people will say decrease tension. Some people will say the antagonist will actually shut down, okay? And the example is typically given, for example, in the biceps and triceps. The bicep being the agonist for elbow flexion and the triceps being the antagonist for elbow flexion. So I figured, hey, let's look at that. Let's look at this from the nervous system's point of view, okay? So in these two graphs, what we have are the representation of the graph. The top graph of the blue line is the neuromuscular energy that is being used by the bicep, okay? And on the bottom graph, the green line is the neuromuscular energy that is being used by the tricep. Now, for this experiment, I had a probe on my bicep and one on my tricep, the long head. And at the top of the experiment, I started with my arm right down next to my side with my elbow with zero flexion. And as you can see, there is zero neuromuscular energy being used by that bicep, but there's already something happening over here in the tricep. So then when I flex up to 90 degrees right there, that's where I'm at 90 degrees, you see that response by the bicep. But look, the tricep does not drop off to zero. So right there, folks, we can see that reciprocal inhibition is not a law. It is simply an opportunity. That bicep is contracting already, and the tricep didn't completely shut down. Now, let's keep looking. So what I did at about 14 seconds right here is I put a 20-pound dumbbell in my hand. And as you can see, there's a response to my bicep. My bicep, the amount of neuromuscular energy to my bicep increases, but look at this. The neuromuscular energy that's going to my tricep also increases. Now, notice I don't have these graphs superimposed on top of each other because you don't want to compare the amplitude of one to the other, right? That's like comparing apples and oranges. So what we're looking at is we're just saying for the amount of activity that was available in the tricep, it actually increased as the bicep increased its effort. Then, check this out. At about 19 seconds, then I pretended like that 15-pound dumbbell was now 100 pounds. So what did I do? I had to squeeze my bicep really hard. So then where did that extra resistance come from? You guessed it, the tricep. And look at that. Look at what happened to the neuromuscular energy in that tricep. It jumped way up there. So again, folks, say it with me now. Reciprocal inhibition, it ain't a law. It's simply an opportunity. And we can see that as I'm activating or increasing the amount of force, the amount of tension, the amount of neuromuscular energy that is going to that bicep, the tricep did not shut down. It is specific to the circumstances, specific to what I am trying to do. Now there's more. So that's the isometric scenario. What happens when you add motion? So for the next chunk, we're looking at elbow flexion from 0 degrees of elbow flexion through full elbow flexion. All right, I did 3 different scenarios, one with a very light weight, one with a really heavy weight, and then the third one, I used that kind of flexing, like squeezing as hard as I could, moving through that range of motion. So here's what we've got. Look at this first deal. So you got the tricep hovering along the bottom there. Again, it looks pretty dinky and insignificant. And you can see the waves in the bicep activity as I go through the range of motion. And you also see that there are some little waves of tricep activity. But again, these two are smashed together in the same graph. So it makes, you're comparing apples to oranges, and it makes this very hard to really distinguish how much is going on or how little is going on. So what we're going to do next is we're going to look at these same two graphs, only we're going to separate them so we can see them in their own relative scales. We've got the bicep on the top graph, the blue, and the tricep on the bottom graph, the green. So as you can see, as you start to squeeze that bicep, you start to see that spike there, your tricep is not shutting down. Now, if you pay attention though, look at what's happening between 8 seconds and say 12 seconds. Between 8 seconds and 12 seconds, what we've got there is we have the bicep looks like the activity is backing off because that's the eccentric contraction. We can talk about that some other time, why that decreases during the eccentric contraction. It's very, very cool. But if you look at what's happening with the tricep, there's actually an increase in what's going on down there. So there seems to be this relationship, a relationship, but it certainly isn't a turning on and turning off. There might be a backing off to allow for motion, and there's more. Okay, now I don't want to completely blow off what we just saw in that last example, where as the bicep decreased the amount of neuromuscular energy that it was using, the tricep increased the amount of neuromuscular energy that it was using. That is a great example of this reciprocal inhibition, right? Or reciprocal innervation, as it was originally called. But as we can see, it's not just as simple as that. Now let's look at another example. This time I'm doing a bicep curl with a heavier load, okay? Heavy load. And again, the tricep is not doing nothing. It's doing something, and it has that same sort of undulating pattern up and down. So we've got the bicep increasing. That's the top trace in the blue. And down at the bottom, we've got this tricep. That's interesting. It's increasing right there too. All right. But then as the bicep starts to decrease right here, tricep seems to be holding steady. Then they're matching again right there, matching here. And then there's a slight offset right there. Okay. So I just want you to see that it's not as simple as you contract the bicep, the tricep relaxes. They are often doing a co-contraction around that joint, even though the bicep happens to be winning what I love my mentor called this, the tug of war. All right. If you ever heard that before, it's probably from Tom Purvis or from one of the RTS courses. Really cool stuff too. And just when you think you've got it all sorted out, let's check out this last example. Okay. We're going to do another bicep curl, elbow flexion. And this time we're going to use a relatively light load, 15 pounds, but I'm going to pretend like it is 100 pounds. So I'm really squeezing really hard with that bicep. Now check this out. Look at the tricep, okay? Instead of having that typical undulating pattern that we saw that was pretty distinct before, this is a lot more flat, right? This is a lot more, there's not as much up and down motion. It is providing the resistance to the bicep. And you can see the bicep has that same kind of undulating going up and down motion, up and down, right? As I'm going through the rep, whereas this tricep is just providing that resistance so I can squeeze as hard as I can. Pretty darn interesting, huh? Reciprocal inhibition here, not happening. And it is based on the demand. Well, all right. I hope that was fun and interesting. And most of all, I hope it's useful. If you're finding that you don't know quite what to do with this information, reach out. I'd love to talk to you about it. We can do some stuff over email, whatever. And next up, we're going to be looking at the quads and the hamstrings. We're also going to look at adductors and abductors and how they work as we do things like leg presses and squats and knee extensions. Okay. So there's more to come, because remember, after that, we're going to get into some trunk stuff. All right. See you soon.